All right, this week we're going to talk about matrices, and it kind of goes hand in hand with systems of equations. We can use matrices sometimes to solve for systems, and so it's kind of a natural progression from what we did last week. Before we learn how to solve them with systems, we're just going to talk about matrices in general really quick. There are some operations of matrices that we're going to do during this lesson. If you're interested, maybe just look up matrices on the internet. A lot of computer programs use matrices. Matrices is used a lot in the real world, and it's pretty cool, and it's definitely worth looking into. Okay, so a matrix is a rectangular array of numbers enclosed in brackets. Like I said, many computer applications use matrices to organize and work with data. We're just going to talk about the main properties and talk about some operations. And so they're named by capital letters. So, for example, A equals this matrices. And again, it's got the little brackets, and so that's how we know it's a matrices. And it is counted by rows and columns. So rows go left to right, and columns go up and down. Think of a column of a house, how it goes up and down. And so this example, A would be considered a 2 by 3 because it had 2 rows and then it had 3 columns. So you'd say it's a 2 by 3 matrix. And it always goes rows by columns. So for the two matrices to be equal, they must be the same size and have corresponding elements equal. So this is B, and we want to know if B is equal to A. They're definitely the same size. Yes, same size. But are the corresponding elements equal? So you're looking at these. Okay, 4 and 4 is the same, but 2 and negative 2 is not the same. Negative 5 and negative 5 are the same. 0 and 0 are the same, but this 4 and 6 are different than this 1 and 8. And so they're similar, but they're not exactly equal to each other. They are the same size, like we said. Okay, so find the values of the variables for which the statement is true. And so assuming they are equal to each other, we can set where the matrices correspond with each other, equal to each other. So for example, this 2 is equal to this y minus 2. This 0 is equal to this 0. This x plus 1 is equal to this 4. And this w is equal to this negative 5. So for example, if we wanted to solve for x, we know x plus 1 equals 4. So if I were to solve for that, x would equal 3. Or for the y minus 2 equals positive 2. So y would equal 4. And so you see the top left goes with top left, top right goes with top right, bottom left goes with bottom left, so on, so on. And w's already solved for us. W is equal to negative 5. You can do the same thing when you add or subtract matrices. The corresponding elements go together. So if I wanted to add this, then it would be 10 plus 2 goes together to get my new matrix. 5 and 8 go together to make that new one. And negative 1 plus negative 4 go together to make that new last number. So this matrices would be if we were to add them together, the new one would be 12. Let's see, 13, negative 5. So we use the first ones to make the new first one, middle ones to make the new middle one, last ones to make the new last one. And we added them because that's what it told us to do. You can do the same thing with subtraction. So these two are going to go together. 5 minus 2 is 3. These two are going to go together. 2 minus 4 is negative 2. These two are going to go together. Negative 1 minus 5 is negative 6. These two are going to go together. 1 minus 0 is 1. 8 minus 11 is negative 3. And 3 minus negative 2. Minus negative 2 will become a positive 5. So the addition and subtraction are pretty easy. You can also multiply matrices, which is a little harder, but the one that we're going to talk about first isn't too terribly bad. So scalar multiplication, let's say C is equal to the matrices 2, negative 3, positive 1, and we want to find 5C. All we're going to do is multiply that constant. It's almost like distributing to that entire matrices. So it will become 10, negative 15, 5. So we literally distributed that 5 to each term to find 5C. Now, normal matrice multiplication is a little harder. Probably the most difficult part of the matrices. So the first thing is, let's say the matrices is of size m times n and b is n times p. The first thing you need to know about multiplication is if I were to multiply these, the middle ones need to be the same, but the new matrix will be the outside. It'll end up being m times p. For example, this one is a 2 by 3, right? And this one's a 3 row by 2 column. And what that says is these need to be the same for me to be able to multiply. But when I multiply them, the final answer is going to be a 2 by 2 matrix. So yes, we can multiply them because the 3's were the same. And the final product will be a 2 by 2. So let's go ahead and do it. It explains what I'm going to explain to you here, but I'm just going to explain it. So to get this first term, we need to do first row by first column, yes. And so it's kind of weird until you see a couple examples. So you're going to take the first one, 1 times 2 plus negative 1 times 0. So it's kind of like the first ones times each other plus the second ones. Okay. Okay. And then for the second one, we're going to do still the first row, but the second column. No, I lie. Sorry. I lied to you. I've been saying row and column this whole time. Okay, ignore me. Ignore me, ignore me, ignore me. Okay. Sorry. I told you multiplication's hard. It's hard to think about. Okay. It's this row times column. There we go. Okay, we're going to do the same thing except it's row times column. So first row times first column of the second one. So 1 times 2 plus 5 times 3. That's going to be that first one. And then the second one is going to be first row. Okay, so that first one's going to go there. And then the second one is first row, second column. That's going to go there. So that's going to be 1 times 0 plus 5 times negative 4. Okay? And so once you do that, then you're going to take this second row and do the same thing basically. So we're going to do negative 1 times 2 plus 2 times 3. I've already used that one. We're going to take it again and do the second column. 1 times 0 plus 2 times negative 4. That's going to go there. So I'm going to go ahead and simplify. That'll become negative 8. This one's negative 2 plus 6. That will become 4. 0 times negative 20. And 2 plus 15, that'll become 17. So see how, kind of see how we did that. So I'm going to do that one more time. So to get the 17, I did this times this. To get the negative 20, I did this times this. Plus, you know what I mean. And then to get the 4, these two. And to get the negative 8, these two. Don't worry, we will do more examples. And depending on what kind of size it is, depends kind of how you're going to go about it. Okay. So the first thing that you need to look at when you're doing multiplication is, this is a 2 by 3. This is a 3 by 2. See if you can even do it, and we can because these are the same. And then our product's going to be a 2 by 2. So there's that. And here we go. So we're going to do kind of the same thing. We're going to do this times this, except now there's going to be a lot more numbers. Okay. 1 times 2 plus 2 times negative 4 plus negative 1 times 5. This second one's going to be this times this. So 1 times 1 plus 2 times 0 plus negative 1 times 3. This third one's going to be this times this. 0 times 2 plus 5 times negative 4 plus negative 3 times 5. And then this last one's going to be that times that. So 0 times 1 plus 5 times 0 plus negative 3 times 3. So let's see. 2, negative 8, negative 5. Oh wait, what, I put a 5 there, that's a 3. Whoopsies, sorry. No, that is a 5. 2, negative 8, that's negative 6, negative 5, so that'll be negative 11. Okay. This next one, 1, 0 goes away. Negative 3, that'll be negative 2. This one, 0 goes away. Negative 20. Negative 15. That'll be negative 35. And then this one, 0, 0 goes away, so it'll be negative 9. Pause if you need to. This one's just multiplying everything by 1/2, so it's not too bad. That'll end up being 5, negative 1, 7, 5 halves, 0, negative 2, 4, 10, negative 1/2. Okay. All right, always check. This is a 3 by 3 times a 3 by 2. These are the same. So our final product's going to be a 3 by 2. If you want to pause, it's going to kind of go like this. Still this times this. Right, and then this times this. So on, so on. Here we go. Pause it if you want. See how much room I have. Okay. Okay, 1 times 0 plus 0 times 3 plus negative 2 times 0. Then the next one's going to be this times this. 1 times negative 5 plus 0 times 1 plus negative 2 times negative 2. Ooh, I'm right on the edge, sorry. Okay. Now we're going to move on to second row, first column. 1 times 0 plus negative 1 times 3 plus 0 times 0. Then to get that second column, I'm still going to do that second row, second column. So 1 times negative 5, negative 1 times 1, 0 times negative 2. Okay, we're almost done. Last row, first column. 3 times 0 plus 4 times 3 plus negative 2 times 0. Then last row, last column. 3 times negative 5 plus 4 times 1 plus negative 2 times negative 2. Okay, now the fun part. Now we simplify. Alright, this first one, 0, 0, 0, that's just going to be 0. 0, 0, that's going to be negative 3. 0, 0, that's going to be 12. Ooh, I love working with zeros. Okay, that 0 is going to go away, so negative 5 plus, that's going to be positive 4, that'll be a negative 1. 0 is going to go away, negative 5 plus negative 1, that'll be negative 6. And then, let's see, negative 15 plus 4 plus 4, that will be negative 7. And we ended up with a 3 by 2, as we said we would. Multiplying is by far the hardest part, so definitely be patient with yourself. Look back over these if you need to.